solar energy, anywhere. Source, Science Illustrated Australia. By visualgk.com. On dry land, huge solar power plants conquer the deserts. Major solar parks have already seen the light of day in desert regions of China, India, Egypt, and elsewhere. But world's largest solar infrastructure network project is the $30 billion Australia-Asia Power Link of the Sun Cable Company. This will harness and store solar energy in the Northern Territory of Australia for 24/7 transmission to Darwin and Singapore via 4,200 km long high-voltage direct current transmission system. But, the Sun Cable Company went into voluntary administration earlier this year. Its assets have been bought by a consortium, who still hopes the project can eventually find its way to a successful completion. Pros: a desert location close to the equator optimizes the quantity of sunlight. Cons: getting the power to overseas consumers has proven expensive. On the water. Sunlight and wind divide ocean regions. China has had floating solar parks located in lakes for years. Recently 12,000 solar panels were installed in Europe's biggest dammed lake, Alqueva, in Portugal. Solar cells will also be placed on water to complement wind turbines. Offshore wind farms are often off-limits for shipping, so could be used for solar cell panels as well. Pros: solar and wind power share the cables to the onshore electricity grid. Cons: salty air and spray can wear down the solar cells. In the air. Flying solar power would work around the clock. Outside of the hour of darkness, cloudy weather is solar power's worst enemy. So French and Japanese scientists suggest placing solar plants above the clouds, with solar cells lining hydrogen-filled balloons that rise to altitudes of 6 to 20 kilometers. There the solar cells could generate power in the day, and send it to Earth's surface via cables. Pros: the solar cells harvest 5 times more energy than on the ground. Cons: the concept requires the development of very light fuel cells. In space. The sun never sets on a power plant in space. A solar plant in space could consist of a huge satellite equipped with solar panels. The satellite converts the power from the solar cells into microwaves that are sent to receivers on Earth, where the waves will be converted back into electrical power. In 2022, the European Space Agency launched a preparatory project named Solaris. According to agency, a space satellite with a length of 1 kilometer could generate about 2 gigawatts of power. Pros: the satellite would receive bright sunlight 24/7. Cons: the project is extremely expensive. On people. You will become a walking solar plant. Bags and backpacks lined with solar cells already exist, and scientists are working on integrating solar cells into clothes, so we could carry our own small personal power plants. Some scientists are working on integrating solar cells into yarn and fibers. Others are designing flexible solar cell film that can be placed on the finished cloth. Japanese scientists have developed ultra-thin film made of organic solar cells. The film can be stretched and twisted, and, importantly, it tolerates machine washing. Pros: the power from clothes could be used to keep your phone charged. Cons: the solar cells are too expensive or fragile to be launched commercially yet. Huge solar power potential. If we make optimum use of solar power potential, we could harvest 23,000 terawatts of power using solar cells. In comparison, the potential of wind and hydropower is 130 and 4 terawatts. Please like, share and subscribe. visualgk.com